Marmalade Quick is a 2D Lua-based engine that runs on top of Marmalade and comes bundled with the SDK. Internally, it uses Cocos 2DX and Box 2D for rendering and physics. You can use much of the functionality of Cocos 2D, but through a simpler and more flexible Lua-based interface. You can do a lot more with much less code. It also takes full advantage of Marmalade's usual build and deploy features. Use a single project and a single codebase, build for iOS and Android on both Windows and a Mac, test and debug in our powerful desktop simulator, and take advantage of a rich ecosystem of third-party integrations. In this video, we're going to build a simple 2D physics-based game using Marmalade Quick. We'll start by creating some sprites controlled by physics and touch, then we'll extend it to more of a full game with scores and controls that scales to any screen size and all in under 100 lines of code. If you're new to Lua, this will also be a great hands-on intro to the language. Let's get started. The first time we use Marmalade, we need to configure a few options. Marmalade has a desktop app called the Hub that manages projects and global configs. Let's fire that up now. I'm using a Windows PC today, but the tool looks and works exactly the same on a Mac. Before starting a project, let's open the dependency checker and set some global options. If this was a C++ project, I'd need to have a C++ IDE installed. I've got Visual Studio, but I'm not using it today. For Quick, there's actually a Lua IDE called ZeroBrain that's bundled with the SDK. For Android, I do need to have the Java SDK installed, so I've installed it and set the path here. For iOS, I need a certificate and a key from my Apple developer account. I've actually used the iPhone sign request tool here that ships with Marmalade to get my certificate. On a Mac, I would just use the regular keychain tool. That's it. We can install additional tools for extending the SDK and debugging if we want to, but that's for another video. Let's create our Marmalade Quick project. We pick Quick, create new project, and give it a name. I'm just going to call it Quick Game. This screen lets us configure the project and also run it in the simulator and deploy it to a device. You'll see the platform list that lets you pick a target. I'm going to leave it as simulator for testing on the desktop. The build option here lets you pick between debug and release builds of the precompiled C++ Quick engine. Debug gives us extra debug output, but is a bit slower, so I'm going to switch to a release build and rely on Lua debugging to start with. We can easily toggle back to debug here if needed later. Let's go look at the code. Under Action, I'm going to pick Open Project Directory to show our generated project. The MKB file here is a Marmalade project. This deals with things like source code to include and build options. The resources folder contains everything that we bundled into our final app. So this includes things like the Lua code itself, textures, sounds, runtime options, and a copy of the Lua parts of the Quick engine. Main.lua is our entry point for all Quick apps. The ZeroBrain IDE is shipped with the SDK, but not set as the default Lua editor yet. So I'm going to change that. I'll just go to Properties and set it so that all Lua files are now opened with ZeroBrain. And I'm going to make sure I pick the latest version. So I'll just go find my Marmalade SDK, and it's under Quick, Tools, ZeroBrain. In the editor, we want to make sure that the interpreter is set to Marmalade, which it is, and then I just use this project directory option to pick the project from the current file. So there's no concept of projects in ZeroBrain, it just finds the file you're using and then runs that. We can run and test from the IDE or from the Hub. The IDE lets us do breakpoint debugging, stack view and so on, but we'll leave those for another time. The Hub actually provides some extra debug output via its console, so typically what we do is we switch to the Hub and run from there by hitting the Run button. You can see our output here and the simulator running our app. By default, this Quick app has nothing in it apart from its printing. This is my app to the command window. Let's add some graphics. First, let's grab some textures to use. I'm going to take these from the SDK's examples folder. So under Quick, there's a nice little selection of example assets. We're going to use these two and just paste them straight into the folder alongside our code. Back in our code, we're going to use the global director object. The director is used to create and manage any visual nodes and add them to the current scene. So I'm going to create a sprite. And this is going to be our background using the sky. And then let's add a ball as well and give it some physics. We can easily get the screen sizes like this. And we're going to put it in the top middle of the screen. And one other thing we're going to do here is we're going to offset it slightly using this X anchor option and Y anchor. So basically this just makes the origin of the sprite in the middle rather than the bottom left. One thing to note in Quick is that the bottom left is always the origin. So whether you're drawing to screen or positioning things next to each other, 0, 0 is always the bottom left. And finally, let's use physics. So there is a physics global object, and we just call add node to add any of our scene nodes to the object. So we'll put the ball in, and we'll just give it a radius so that it knows that it's a circular object. We can hit build to check if I've made any mistakes. So I've missed something out here. Forgot to put these in a table. There we go. And now if I switch back to the app, I can just press Ctrl-T to completely reload the Lua environment. And it's displayed our ball and our background. And as you can see, I've made a slight spelling mistake there. Once again, I'll reload. And we can see the ball falling under gravity. Notice that the simulator itself lets us configure lots of different things, so I'll just boot it up again and show you that. We can set things like surface size, and we can generate accelerometer events. Set a fake location, or simulate suspend and resume. We're not going to use those today, but we will use the screen size later. Let's go back to our code. Quick is an event-driven engine, so we can easily set timers and register for various types of built-in events. Let's set a timer to drop the balls at random. I'm going to use math.randomSeed here to make sure we get an actual random number. I'm going to use the OS time to seed it. Then I'm going to create a function called dropBall to do the ball dropping repeatedly and move our ball creation code into it. By default, Lua makes all variables global. We only want to get a handle to this ball during the function, so I'm going to declare it as local here. And then I want to actually create a timer to drop the balls repeatedly. So we'll call it ball timer. And we'll use the system object, which is a global object that does things like handling events. And we'll add a timer. And all I have to do here is set the function to be called. Set how often, so I'm going to have it once every 2 seconds, and set 0 so it will repeat forever. I can hit F7 to check that my code is correct. The code compiles, which means the syntax is right, but doesn't mean I haven't spelled something wrong. We'll find out at runtime. And the goal of our game is going to be to shoot those balls before they fall off the screen. So what I'm going to do is create another event, a touch event this time. And I'm going to call it touch. I could call it anything I want, but touch is nice and obvious. And in this event, we're going to create another ball. So I'm going to copy my ball creation code and just drop it in there. All events like this have a parameter passed to them, which I'm going to call event, and this will contain information about the event. One thing I'm going to definitely do here is use the phase. So I'm going to check whether it's ended. There will be, this event will actually be called twice, once when you first touch the screen and once when you release your finger, and we don't want to drop 2 balls, so I'm just guarding against that. And then for our new ball, we actually want to make it start in a different position, so I'm going to have it starting in the middle of the screen again, but at the bottom. And one thing I've forgotten to do here is that actually I want these balls to drop in random positions, not just in the middle of the screen. So what I'll do is use math.random, and it will now fall anywhere between 0, the left side of the screen, and the right-hand side of the screen there. Once again, check it compiles. So I've forgotten something here. There we go. And finally, I want to actually register for this touch event to happen. So I use the system object again. This time, add event listener, set my function touch, and set the event it's going to be called for, which is also called touch. And once again, check that compiles. Now, our second ball is just going to appear at the bottom of the screen and then fall straight off. What we want to do is fire it. So we're going to give it some velocity. I'll use the ball's physics property and call set linear velocity. And we want to set it to travel relative to where we touch the screen. So we can use event.x and event.y to get the touch position. I want it to be a little bit quick, so I'm going to multiply that by 2. And also, because the ball starts in the middle of the screen, we need to offset it slightly. So we actually want to minus half the screen. And finally, so we can see the difference between our two balls, I'm going to colorize this one. So I'm using the same texture as before, but I'm setting the color to red. And that's it. We've now got a function for dropping our ball repeatedly every time this timer fires, and a function for firing a new ball with a velocity every time we touch the screen. Let's check it compiles again, and switch back to the simulator and run it. Minor error here somewhere on the timer option, so let's go and have a quick look. And that's because I've just misspelled drop ball. So we can debug quite easily through the log there. Switch back, press Ctrl-T to restart. And now you can see I can fire the balls from the bottom of the screen and knock the other ones out of the way. Finally, let's make something actually happen when our balls collide. We're going to add a score counter and then a collision event. So we'll set a score, set it to 0 to start with, and we're going to want a label to display the score. I'll call it score label, and once again we use the director to create this. And let's set its position somewhere at the top of the screen. And set some initial text, so we'll just show the initial score of 0 and give it a color. Now let's add a function to be called when the balls collide, so we're going to call it ball hit because that seems quite sensible. As usual, this gets an event parameter. And once again, we want to check the phase. This time the phase is the start and end of the actual collision. So we'll call it at the start, I think. We want to get handle to the two balls that have collided, so we can do that by getting the event nodes and popping them in a table. And then we're going to loop through our new little table here and apply some animations to the balls to make them disappear. So we can use a for loop. And we'll use a tween animation. So tween is another global object which just applies animations to properties. So the ball is the object being animated, and the things we're going to animate are going to be the scale. So we'll make it shrink down to nothing. And also use the alpha to make it completely disappear. And then we want to also set the score not inside this loop because we only want to increment it once. We'll just do score equals score plus 1. And then also update our label. So we'll just check that compiles. The one thing we actually want to do though is add an event listener to make sure this function actually gets called when a collision happens. So in our ball drop function, we'll just use the ball itself. And we'll add an event listener, which is our function here, for the collision event. quick check to see if I've spelled that all correctly. Looks good. Hit compile. And let's go see it in the simulator again. A couple of little errors here, I think. So what have I done wrong? I've not displayed the score properly there. And I'm also displaying this in the wrong place. So once again, press Ctrl-T to reload. And here's our simple game running. We can knock the balls out of the sky and get points for hitting them. Before putting our game on a device, I'm going to make a few changes. The current game displays the sprites in whatever size they are on file. So if I change the resolution, for example, just switching it here in the simulator, you'll see that nothing scales very well to the screen at all. The other issue is that we're actually not cleaning up any of the objects. These balls are going to keep falling to infinity and slowly growing the memory the app is using. Or, if I actually shoot one, they're shrinking to tiny, tiny objects, but they're still actually there in the scene graph. Let's close this down. I'm going to cheat a little bit now and actually pull open a finished project I used earlier. So in the hub, I'll go to Projects and Import Project. And I've got this project here called Quick Game in 100 Lines. Open it up. So this is exactly the same game, but tidied up a little bit, but I've made sure it stays under 100 lines of code. We'll open it here, open its directory again, as with the previous project. Go into Resources and open our main.lua file. Once again, we need to go to Project and set the project directory to the current file. And let's take a little look at the code. Two things you'll immediately notice is I've got two new files. I've got nodeutility.lua and virtualresolution.lua. These are two helper libraries I've taken from GitHub. The node one lets me scale, pause, and destroy nodes more easily, and the VR one lets me set a screen size to work in, and then it scales everything to fit. At the top here, we've got some do file commands, which just include these two libraries. And then we're setting the app width and the app height. So I've just picked 640 by 960, as these are very common phone resolutions. And here I'm actually setting the virtual resolution using initialize and passing those two values in. Finally, I apply the resolution to the current scene. The other new function here, I've used set default size to set the size of the sky, so I'm making it just stretch to fill the screen. And then also for the score label, you'll see I've tidied it up a little bit by putting a nice colored background in. I've added a little more code generally to make it more of a game and just sort of pretty everything up. In our collision function here, I've made one major change, which is this tween2 function now has an onComplete parameter. This basically tells it to call this destroy ball function once the animation finishes. And in destroy ball, I'm removing the listener and then destroying the ball. This destroy node function is from the node utility helper, and it makes sure that any timers or tweens on the ball are cancelled and removes the ball from the scene graph. The other little change here is that I'm cancelling the timer and speeding up every time we successfully hit a ball. If we scroll down a bit more, as well as our global touch event, I've also got an orientation event. This is basically just to reset up the virtual resolution every time the screen changes size. And then my very final change is I've got an update event. The update event is called on every frame of the game, and I'm using it to basically wait for balls to fall off the screen and then destroy them. I'm also resetting the score to 0 every time you miss one. So let's fire this up in the simulator and see the changes. And you can see, despite the odd size screen I've picked here, everything is scaling nicely. I've made the balls a little smaller for a bit more challenge, and it's showing the score. If I just switch the surface here at runtime, so let's make it thin and tall, it scales to fit nicely, but keeping its aspect ratio. Right, let's get this game onto a device. Back in the hub, I'm just going to switch from Simulator as my platform to Android. I've plugged in an Android phone, and I'm just going to hit Package Install and Run to push to the device. I've already installed the USB drivers for the phone. Marmalade takes care of pushing it over USB. And here we can see our game running on the phone. You'll see that it's running at the device's native resolution. You can fire objects. I can actually pretty much cheat and just fire hundreds of them. And then if I rotate it, everything updates nicely. We can also make a build for iOS, so I'll just switch the platform from Android to iOS, unplug my Nexus and plug in the iPad mini, and hit Package and Install again. And that's it, a quick game on multiple platforms in a few minutes and under 100 lines of code.